Welcome to Building Science Basics. This tutorial will give you the information you need to complete a thorough inspection of your home with an IR camera. Let's start with key building science terminology that will give you a better understanding of what areas in your building or home are important to inspect during an energy assessment. The building envelope is the entire structure that separates the inside from the outside, including the roof, walls, and foundation of a home. Conditioned space includes any area, kitchens, living room, bedrooms, bathrooms, that are heated or air-conditioned to maintain a comfortable living environment. To illustrate this further, unconditioned places in a home may include attics, garages, crawl spaces, and porches. You would not want to pay to heat or cool these areas. It would be unnecessary and costly to maintain its temperature. The thermal boundary should separate unconditioned space from conditioned space and resist the conduction of thermal energy from the inside to the outside in the winter and the opposite in the summer. There are various types of insulation, for example fiberglass and cellulose, that are used to create a thermal boundary. The air barrier prevents heat loss and gain through convection. The walls, windows, and ceilings of a home essentially serve as an air barrier. However, there are many gaps, cracks, and joints that need to be sealed with spray foam or weather stripping to keep conditioned air in the home. Let's take a moment to review what we have learned. Be ready to pause the video to give students time to answer the questions. Press play when you're ready to continue on with the video. Can you answer the following questions? Number 1. What is the entire structure that separates the inside from the outside, including the roof, walls, and foundation of a home? Number 2. What do building science professionals call the area in your home that is heated or air-conditioned to maintain a comfortable living environment? Number 3. What prevents heat loss in the winter or heat gain in the summer through conduction? Number 4. What prevents heat loss in the winter or heat gain in the summer through convection? Compare your answers with this answer key. How did you do? Now we are ready to learn more about the framing or scaffolding of a building or home. You will need to use these terms to describe where you may find a gap in the thermal boundary or a leak in the air barrier. Let's start at the top. Rafters are the diagonal framing members that make up a roof. Studs are the vertical framing members that make up the walls. Wall cavities are the spaces between the studs. The joists are the horizontal framing members that make up the floor. Pause the video here and take a moment to review what we have learned. Press play when you are ready to continue on with the video. Compare your answers with this answer key. How did you do? Next, we will learn about windows. There are 3 main types of windows: single pane, double pane, and triple pane. In double and triple pane windows, in the spaces between the glass, there's an extra insulating gas, usually krypton or argon, which make these windows far better than single pane windows at resisting heat loss. However, if the gas escapes between the panes of glass, visible bubbles may appear and all of the insulating properties of the window are lost. The escaped gas can also cause the glass panes to bow inwards and compress the glass in the center. An IR image of a window with a broken gas seal will appear to have a bullseye in the center area that is colored in a cooler or cold shade, where the glass panes have bowed inward. Pause the video here and answer the multiple choice question. The answer is D. It could be B or C. Now we will delve deeper into how to complete a home energy inspection with an IR camera. In class, you have completed experiments to understand how heat transfers by radiation, convection, and conduction. You may also have seen this classic textbook image that is used to display 3 modes of thermal energy transfer. Let's see what a boiling pot of water would actually look like in IR. We can see conduction occurring in the solid pot handle. It has a distinct thermal gradient as the heat moves through the solid material of the handle. We see convection in the boiling water in the pot. Convection will appear wispy, representing the fluid nature of the medium through which heat is being transferred. Radiation is the glowing warm color given off by all of the objects emitting thermal energy into the environment. Okay, so if we apply what you just learned to this window, what mode of heat transfer is happening in the wooden window frame in the area marked number 1? What mode of heat transfer is occurring at the base of the window in number 2? Also, I have one more question for you. Could you add insulation to this window to make it more heat resistant? Pause the video here to answer these questions. Press play when you're ready to continue on with the video. If you answered conduction for number 1 and convection for number 2, you were right. Also, insulation would not be a good solution to reduce heat loss. However, you could add weather stripping to stop the convection occurring at the bottom of the window. Let's look at other common areas of heat loss in your home and discuss possible solutions by playing Name That Mode. This is an IR image of an attic hatch, which is an entryway into your attic. What type of heat transfer is occurring here? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. You can see convection occurring at the edges of the hatch, where cold air is coming in and your warm heated air is escaping into the attic. You can see conduction happening in the wooden material that makes up the hatch. The mode of heat transfer will determine what type of solution would be best. What do you think would be a good solution to stop convective heat loss through an attic hatch? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. To stop convective heat loss, you would need to seal up any air leaks around the edges where the hatch and the wood framing meet with some type of weather stripping. What do you think would be a good solution to stop conductive heat loss in an attic hatch? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. If you're losing heat through conduction, you would need to increase the thermal resistance of the wooden attic hatch by adding rigid foam board insulation. When warm heated air escapes from your home and reaches your rooftop, it will melt any snow on top of it, and that melted snow will refreeze when it hits the edge of the roof and will form icicles. If you have icicles on your roof, that is a good indication that you are losing heat through air leaks or poor insulation in your attic. Take a closer look at the IR image of the roof and chimney. What type of heat transfer is occurring here? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. The modes of heat transfer occurring here are convection, as the heat moves through the areas around your chimney, the tops of walls that make up your house, and through light and wire penetrations in the attic floor. And conduction, as the heat escaping through your attic floor conducts through the actual roof itself to the outside. What solution would you recommend to stop the convective heat loss from the air leaks in the attic floor? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. To stop convective heat loss, home energy professionals would recommend air sealing your attic, which would include spray foaming chimney chases and areas where tops of walls meet the attic floor joists. Moving on to your walls. The walls constitute a large surface area of your home and can have a large impact on your energy bills if they are not insulated or sealed properly. If your walls are not insulated, your wall cavities will be significantly colder than the wooden studs that frame your house. As a result, the studs will appear warmer than the wall cavities in the IR view. What type of heat loss do you see in the area marked number 1 and in area number 2? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. If you answered number 1 is convective heat loss through the empty space between the drywall and the siding of the house, and area 2 is conductive heat loss through the drywall and the wood studs to the outside, you are correct. What solution would you recommend to resist heat loss in the walls? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. Fiberglass or cellulose insulation both would resist conductive heat transfer, but fiberglass does not prevent convective heat loss, as air can easily move through it. Old fiberglass will sometimes appear black because it acts like an air filter and not an air barrier. Blown-in cellulose is densely packed into walls, so that air can't move through it. And it can be blown into the wall cavities without having to completely open up the wall. But fiberglass would be used if you needed to insulate around pipes. What do you think cellulose is made out of? Cellulose is made out of eco-friendly, recycled newspaper. Other areas on exterior walls that may show heat loss are electrical outlets. What mode of heat transfer is occurring in this IR image? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. Heat is conducting through the outlet cover and convecting through the wall where there is missing insulation around the outlet. An outlet and switch foam gasket is an easy solution that can help reduce heat loss. Fireplaces are another common area that are susceptible to heat loss. What mode of heat transfer is occurring in the fireplace in this IR image? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. The answer is convection. Heated air from your home is escaping through the chimney flue. You could prevent the convective heat loss with a fireplace draft stopper. This is an IR image of a rim joist. The rim joist is the wood framing that sits on top of the concrete foundation in a basement. It holds up the first floor of a home. What type of heat loss is happening here? Pause the video to discuss as a class. You can see that the wooden joist is quite conductive, losing heat quickly without insulation. Also, there is quite a bit of air leaking at the junction of where the wall meets the concrete foundation and flooring. What solutions would you recommend to solve this problem? Pause the video here to discuss possible answers with the class. Press play when you're ready to continue on with the video. To solve this problem, you could add rigid foam board to resist conduction and spray foam to resist convective heat loss. It is even possible to add spray foam to the entire rim joist, as it will resist both conductive and convective heat loss. However, it is more expensive than rigid foam board. The 3 biggest problem areas in buildings are heat loss, air leaks, and moisture problems, known in the industry as HAM. The IR camera is a very useful tool to be able to identify moisture problems in a building structure. Wet areas will take longer to heat up, so appear as a cool spot without a lot of definition. If you are doing an IR scan outside at night, a wet area will take longer to cool down, so it will appear warmer. You have completed the Building Science Basics tutorial and are ready to begin your Home Energy Analyst tasks. Before you go home with your IR camera, be sure to keep in mind the optimal conditions for completing an IR inspection. There should be a temperature difference of at least 10 degrees Celsius and 18 degrees Fahrenheit between the inside and outside of your home. And it's best to do the inspection 2 hours after sunset to decrease the effects of solar radiation. Before you go, remember that your family may be eligible for a free home energy assessment by building science professionals. Go to masssave.com to learn more. Have fun!